What the hell? Doesn't even go down as far as it did before. Well, that'll do. Okay, so I'm just about to start closing this up now, and this is how I've arranged it. I cut down the plastic case for this. I wanted to keep it inside this, or inside something, to stop that cog for the gear in there that's spinning around. It could catch on stuff and that would be just horrible. There's also this piston, the back of the piston's thumping up and down too, so this plastic case is a perfect thing to stop that. And we have the garden hose stuck on the back of the pipe there. That's going to come out pretty much straight out like that, and this whole thing is going to go in here, of course. Fits in there just nicely, and then one of these hoses is going to come out one of these holes, and the vacuum in hose is going to be another one of these plastic tubes going in. I decided to go with this stuff because well, it fits perfectly on the back of that nozzle on the airhawk thing, and also because I have these taps, quite a few of these various things and fittings, T-joints and all that kind of stuff to use with it. And also because I did some tests here and it seems to be the best thing, the best material that glues to PVC pipe. So that's it in there, the black one. Sorry about the lighting here, it's not very good. But that black pipe in there sticks like, I don't think I could even pull it off. Oh yeah, I can. Okay, I can pull it off. But anyway, it sticks really good, and I've been using this stuff for that. This black pipe is actually PVC, which is probably why it sticks so well with that cement, of course. Tried a few other things. Unfortunately, silicone doesn't really stick very well at all, which is usually a good thing in most cases, but for this particular thing, it would have been nice if I could have stuck it a bit better to PVC, because I want to have these wires coming out of there. I also tried this liquid electrical tape, which did a pretty good job. It's better on the silicone than the PVC glue is. The PVC glue just couldn't glue the silicone at all. Anyway, on the back of the lid here, so there's the two in and out pipes for the air, and then we have just two holes here for the battery terminals, or the power for the thing. I made them separate because you can get a better seal around the hole. There's less sort of wastage. If I was putting two in together, the hole would have to be bigger and there'd be a gap beside the wires, if you know what I mean. For this one here, this is the I2C connection for the barometer. That did sort of fit a little bit better in one single hole, I thought. So that's the barometer on the inside there. And to sort of pack around this stuff, I decided to use some of this foams called gutter boss, and you put it in your gutters to stop leaves from falling down into the bottom of the gutter there. But this is pretty good because it's open cell foam, so when the vacuum forms inside here, it's not going to change in shape and nothing's going to be pushed around, because I don't want this pipe to be pushing on the back of the piston thing. So it's good in that respect, and also the fact that it doesn't expand like a closed cell foam like pool noodle or something, I think would expand, and it would mean that this pump thing would become tight against the walls of the cylinder and the whole thing would start to vibrate a bit. So I'm hoping that because this foam is not going to change, this pump will be able to vibrate inside the tube without the tube itself actually vibrating. Let's hope. The other nice thing about this foam is that it has quite a low friction on the PVC surface, because this whole structure, when I have it packed in here, needs to be able to turn inside the pipe like that, because I need to put this on, and my wires and my pipes are all going to have to be turning around as I screw this on. Well, unfortunately, I could only put about half as much of this foam in as I wanted to, because it gets a bit tight to turn, and the way I'm turning it is by poking this file in there. It's just like a steel rod, basically. And if I hold this here, this will like stir the inside of the pot. Otherwise, the only way that the insides can turn around is by pulling on these wires here, which is not very good. If I do it like this, I can turn it. See, nothing gets stressed. This is not a very cool way to do it. If I was doing this again, I might have just... there we go. I might have just got two, like one of these on both ends, so that I could just press this on. The trouble is you can't take it off, though, if you do that, because you're probably going to have to glue it or silicone it or something. But this way here, the way I've done it now, I can just take this off fairly easily. Hopefully this will just come out. There we go. So now it's nice and tight, sealed up, and hopefully nothing's shaking around. That's good. So here's the chamber itself finished off, and this end is going to be permanently closed. This end has a screw top so I can open it and get inside again. In hindsight, I didn't really need to do that. I probably should have just made both ends permanently sealed, because it would have avoided the problem that I was talking about with having to turn this section. And it would have been a lot cheaper too. In fact, in hindsight, I'm not sure if I should have really done this project, because this PVC stuff is expensive. I couldn't believe it. The pipe, 1 meter of this pipe, which is unfortunately the shortest piece I could get, was $45, 45 New Zealand dollars it is. These pieces are about $10 each, and if I didn't need to do the screw top, that would have saved me $10, because I wouldn't have needed that piece. I could have just got 2 of those. Yeah, anyway, so this project started off being something that was going to be a cheapie, but ended up costing quite a bit, unfortunately. So on this one I have, what do you call that, liquid electrical tape. Seems to be working alright. And PVC cement for these two, because these pipes are actually PVC too, and you can see that the cement has melted, at least one of those there, it's melted it quite nicely together. So I'm thinking they should be fairly well sealed. And for the electronics, we have power for the pump, so that's just directly going to turn it on when 12 volts goes on there. And this is an I2C connection with the 4 wires for that. So only the minimum necessary things are going to be inside the chamber. Okay, so this is the first incarnation of this arrangement. I've mounted everything onto a wooden plate, and the wooden plate and the mounting will stay as is, but all this wiring I'm hoping to tidy up a little bit. But I just wanted to give it a quick test to see if everything's working properly before I launch into arranging it so that the Arduino can control the pump by turning it off and on by relay. So I have the outlet, or the inlet actually. This is sealed off with the garden hose tap, and you'll see that, see, this is a bit of a pain. It only takes a few seconds to get to, let's go down to half an atmosphere. Right, so that's half an atmosphere. What was that, 5 or 6 seconds maybe? So that's way more than you really need to do vacuum bagging. And you can see that it's leaking a little bit. Why does it not want to focus sometimes? It always focuses when I put my fingers in front of it. Must like my fingerprints or something. Anyway, so there's a slow leak. And interestingly, it doesn't seem to matter how low the pressure is in there. It doesn't affect the leak speed very much. So even at, say, 950 millibar, which is only 50 millibar less than atmospheric pressure, the leak speed is about the same. Actually, no, it's a little bit faster now, I think. But anyway, so now we get a nice hissing sound when I open this tap. And we get back to about 1,000. So it's working quite well, apart from that tiny leak. The tiny leak is not really an issue, because it's not fast enough to really affect anything. And I'm planning to disconnect this piece from my vacuum bag anyway, so the pump's not going to be a part of it. And I don't think the leak is in the tap or the hose. I think it's probably somewhere around these PVC cement connections, or possibly around this PVC cement connection here. It's just looking a little bit suspicious, so I'll put some silicone around those, and also around PVC cement joins, maybe even around the screw top join. Although I won't do that actually to begin with. I think that's probably okay. And then I will use one of these relays. This is the relay that I salvaged from the tire inflator thing, and I thought I might as well use this to sort of complete the cycle of reincarnation of the tire inflator into a pump. But trouble is with this one, you can see there the second line of text, it says 12 volts DC, and it was using the power from the lithium ion batteries, which is 10 to 12 volts, to trip the relay to close the circuit and start the pump. But my 5 volt Arduino is not really going to be able to do that. So I'm just going to use one of these things that I got off Banggood ages ago, and it's been sitting around for like 3 years wondering when it was going to be used, and here we go. I'm going to use it today. And this has a nice feature in that it's got a little transistor there, so that
you can plug a servo cable style connection in here, so you've got ground and 5 volts coming from the Arduino. It possibly doesn't actually need to be 5 volts, maybe it could be more than that, but this relay itself will trip at 5 volts, so it's a lot better than the salvaged one. And then the signal here, when this goes high, this little transistor will close the gate, and the 5 volts or whatever you put on the middle pin will go into the relay to trip it. And then these two connections that I've marked here with the little black lines, this is the normally open pair. You have a normally closed on the other side as well, so it's quite handy, this little thing. Much more handy than the this one over here would have been, so I'm just going to trash that, I think. Right, here's the tidied up version. Yes, it is tidier, trust me. I decided to use one of these little boards that I had for my balloon project because it's quite a convenient way to mount an Arduino Pro Mini and have some breakouts coming out from it. And it also has a position for a little voltage regulator and a voltage divider, so you can measure the voltage of the battery as well. I thought I might as well do that. It's not very convenient for I2C outputs, and I had to cut some of these wires and put some other wires underneath on the back to make it all convenient, but it's fairly convenient now. And I've changed from using this switch to just directly turn the pump off and on. That's now going to be the off and on switch for the whole system. So this plug here is going to be unused. Maybe didn't really see any reason to cut it off, but it's not doing anything. So this switch turns the power on here, and obviously everything's running. You can see the screens come on there, and there's a little LED over here, or a big LED really, and this is turning off and on every 4 seconds via the relay. The relay actually has, I realized, a little LED of its own on there, so I didn't actually need this one, but it's kind of nice just to confirm that everything's working and the power is coming through from the battery as we're intending. So this bit here, I'm going to have to adjust something else, put these two on top, cover this all up, but while it's still visible what's in there, I thought I'd show you right now. And I've found this in my bag of bits that I've had for ages. I dismantled an old Futaba transmitter ages ago, one of the very first ones I got back in Japan, and I had no reason to use these, but anyway, it's another day of using things that I've had sitting around for years. So anyway, this dial is going to be used to set whatever pressure you want to be the target, and it's looking quite nice. The switch will be to actually enable the pump to do something. So when the switch is off, this is just going to be a monitor to let you know what the pressure is inside. Anyway, that's the switch, and then VBAT is obviously the voltage of the lithium-ion batteries there, reading through the voltage divider. The chamber itself is out in the garage drying. I put some silicone around those possible leak spots, and we'll see if it makes any difference when we put it all back together. Okay, here's everything back together. So this will be the final form with this little control panel on top, and I'm going to have to put you down close to this to show you, because most of what we're going to be looking at next is on the screen here. So when I turn it on, we'll see that we get 4 numbers showing up there, and I'll explain what those are in a little bit more detail in a minute. But this is the main screen that you would see during normal operation, and the top number goes from 400 to 950. This is the goal or the desired pressure in millibar that you're trying to achieve, and you'll just have to ignore the fact that these numbers are not very accurate. There's a number of reasons why that is. The analog read function is not particularly accurate. This dial has rather strong clicky detents on it, so you can't put it wherever you want anyway. And I'm also storing values in the EEPROM in a certain way that loses precision, and then displaying floats on the screen is a bit dodgy as well. So there's supposed to be 400, and a lot of these other numbers are going to be a bit off as well, but just ignore that. Anyway, the next number is the current pressure, which is the atmospheric pressure in the room, because I have the tap open, yes. The next number is the temperature in degrees Celsius inside the chamber there, and then 11.3 is the voltage of our battery, which is running everything. Now, if I were to start, let's turn this off again. If I start this with the switch in the down position, we get to into some settings. So this is the 4 numbers that we saw before. The numbers that we were looking at before were coming from the EEPROM. So this is where you get to put them in the EEPROM. So the minimum voltage is a value, obviously, as the battery wears down. You don't want to damage the battery. Now I'm planning to run this thing overnight to make sure it keeps the pressure at a desired level. So I'm going to be asleep and I'm going to be running it for long periods of time. So if something goes wrong and there's a leak in the vacuum bag, I don't really want it just to sit there running and running and running and ruining the battery and getting hot, and yeah, could be problems. So I'm setting a minimum voltage after which it will turn off. So that goes from 9 volts to 13. Now there's a bit of a bug I discovered. I'm actually retaking this video right now because it got long and painful, because I didn't realize there was a bug in that all of these setting values, when you turn the dial hard to the left so that you get this absolute minimum value there, you actually get the maximum value of this range. So if I had have done that, I would have got 13 or 12. No. Oh, there's a bug. There's a bug there somewhere. So I'm not going to put it hard over. I'm just going to click at one number to the right. So that's 9 degrees for my minimum voltage. And we click the switch like that to save it. Maximum temperature, we'll just put that up to 27. I'm not going to get anywhere near that today. Maximum time. So this is a number of seconds that you want the motor to run in one go. So this is again to stop it from getting too hot, is mainly what I thought of, but it also could be useful to run it just briefly while you're actually pulling the vacuum to begin with, and you're maybe fussing around with the vacuum bag trying to push things into place and so on. So it could be handy just to have it turning off and on instead of sucking everything out in like 5 seconds, because it's quite fast, this pump. So anyway, I'll set this to 3 seconds. So what this will do is, after running for 3 seconds, it will turn off, and then it will turn on again after 6 seconds. So whatever you put in here, twice as long it's going to rest for, if that makes sense. So if this was 2 seconds, it would run for 2 seconds and then rest for 4 seconds. Now if I had a bit more memory to spare, I would make a second parameter so that you could actually say how long you wanted it to rest, so that you could have a bit more versatile. But I've been having a lot of problems with this sketch because the U8 2G library that I'm using to display things on the screen takes up a lot of global memory, and I'm getting this message at the bottom: low memory available, stability problems may occur. So I'm not entirely sure if it's my code that has a bug there regarding what I was just saying about the lowest value of these ranges not getting set properly. So we may actually see problems. But anyway, that's the time. And then finally we have a margin in millibar. So this just means that when the pressure in the chamber reaches the desired pressure that you set, it's not going to turn off immediately, because then if there's a little bit of a leak, it would turn on again immediately, and it would just sit there turning off and on, off and on, off and on like crazy. So this just means that we want it to go, say 40. 40 seems reasonable. So instead of meeting the desired pressure, we want it to go 40 millibar below the below the pressure that I set before the pump will turn off. And then as the pressure increases, it will need to go 40 millibar above my target pressure before the pump turns on again. So it's a bit like the thermostat in a heater that prevents it from just switching off and on like crazy. Anyway, now I'm a little bit worried that those numbers didn't get saved, so I'm just going to I just push reset on the Arduino there and see if they got saved properly. So we're looking for 9, 27, 1.9 and 40, close enough. I think we'll be okay. Alright, so my tap is open, and I'm going to set the target pressure to about 800-ish. That should be... Alright, 800. Now it's not going to be able to reach that pressure because the tap is open, but let's just see what it does. So it runs for 3 seconds, and then it should rest for 6 seconds. Or is it 2 seconds and 4 seconds? Something like that. But the numbers, like I say, the numbers are all a bit off. But you can see the voltage sagging quite a bit there when it runs. So I actually had to charge this up a little bit before I did this retake, because it was continuously going below 9 volts, and 9 volts was the lowest voltage that I had set for my range. But you can of course just plug this in here and then you don't have that problem. But right now the battery's at a level that it can handle it without sagging below 9 volts too much. next thing I wanted to show was, I'm just going to turn the tap on, or close it rather. So now, when I switch this on, we should actually go down to about 750 millibar, because my goal is 790 and my margin was 40, right? So it should go to 750-ish. Of course, it's going to rest each time. No, is that? Oh, is that close enough? That's weird. I thought it would have gone to 750-ish. Yeah, it's still a little bit odd. I've only spent probably about 3 hours on this code, and half of it was trying to figure out those memory issues and getting things to display on the screen properly. So I'm actually kind of testing this right now in front of you. I hope you don't mind. But anyway, let me open the tap a little bit so that our pressure... Oh, by the way, it's not leaking as fast as it was before. It's still leaking, but it's a little bit slower. Not much slower, only about half of the speed. Anyway, let me open the tap a little bit, and when this gets to about 830-ish, the pump should turn on again. We switched on, yes. I've left the tap open, so the numbers seem a little bit off. It should be... Oh, I see what's happening. It's because it has to rest for 4 seconds before it's allowed to turn on again. So the program is pretty basic. Like, for example, what's happening here, the reason that the pump turned off was because it met the desired pressure. So in that situation, we don't necessarily want to force it to wait 4 seconds before it starts again, because the condition that stopped it was not the time. So there's a lot of ways this could be improved, but for now it's working fairly well. So let me close the tap now, and I'll just show you how it would work. I think it's going to stay off now. Okay, it's alright. And then if I want to decrease the pressure, it will turn on again when we get to 760. Okay, so now it's down to 680, and I can turn it down, and it will meet whatever pressure I want. Unfortunately, there's no way for the Arduino to release the pressure in the chamber. So if I turn my desired pressure back up to, say, 800 or whatever I had before, it can't do anything about that, because the only way for the air to get back into the chamber is for me to physically open this. However, seems to be working fairly well, apart from those sort of niggles and bugs and memory issues. So I'll put the code for this in the link in the description if anybody wants to have a look at it, and not really expecting anybody to set up anything like this, especially if they're going to be paying lots of money for this expensive PVC pipe or something like that. But anyway, that code might be useful as a starting point for some other project perhaps. So anyway, thanks for watching, and I'll see you next time.